In this video, we are going to look at common and natural logarithms and logarithms of other bases with and without a calculator. Okay. So here's an exploration you can do for yourself. First of all, find a solution to this equation. 10 to the x equals 356. And you can work through that and then come back, and I will talk about how we might find that right now. And then there's also the exploration of using your calculator. So you can pause this video and then come back and we'll talk about that. Okay, so let's look at this. 10 to the x equals 356. Right now, one way we could solve it is by putting it into our calculator and letting the calculator do the work for us. So 10 to the x power in one, and then 356 in the other. We have to change our window. The window from 0 to 3 should be okay, but we need to go from, let's go from y min of 350 to y max, not 35, 350, and a y max of 360. Let's graph that. There are the two functions. You can see they do intersect. So let's find that intersection point, and that would be our solution. First curve, second curve, intersection. Our guess is, and so it's 2.551. So this would be x equals 2.551. We can check that by taking in our calculator and do 10 to the 2.551 power, and it should be very close to 356, which it is. Okay, so our round off error is a little bit of round off error there, but okay, that's how it's done right now. And we don't, algebraically, we don't have any way other than guess and check to figure that out. We keep plugging in numbers until we get closer and closer to 356. Well, what we're going to learn today is going to give us a way to solve those types of problems. So if you did this other exploration, you'd be saying when you type these into your calculator, you got 3, you got 4, you got, this is the log of 0.1, by the way, and you got -1, and this is the log of 0.01, and you would have gotten -2. And you'll notice that 10 to the third, of course, is 1,000, but the 3 and the 3 match. 10 to the fourth is 10,000. 10 to the -1 is 0.1, and 10 to the -2 is 0.01. And so you can see the connection there. These exponents are the same as the answers to those log problems, and that's a key thing. A logarithm is an exponent. Very important thing to remember about logarithms. A logarithm is an exponent. Common logarithms are base 10. Okay, and you're going to see right here the graph of f of x equals 10 to the x power is shown right here in figure 1. You can see there's the graph of y equals 10 to the x power. It's a one-to-one function. Okay, it has an inverse. Okay, so remember our inverses, we reflect them over the y equals x line. So this is, again, is y equals 10 to the x. This is the inverse of that, which is going to be y equals the log of x, log base 10 of x. And as with all inverses, they're reflections over the y equals x line. So very big thing, important thing to remember here. The log of v equals u, if and only if 10 to the u power equals v. So these are, I wanted to show you that these are related to exponential functions, and these functions and exponential functions undo each other. A couple of the things that we know is things like this. The log of 10 to the fourth power is 4. And 10 to the log of 6 is 6. It goes along with the lines of, and the general rule, I should say the general rule here, those are the two general rules. But essentially what's happening is this log and the 10 are canceling each other out, and then what's left is the 4. Same thing here. The 10 and the log are canceling each other out, and what's left is the 6. We'll have a general variation of that in a few minutes. Alright, so we want to evaluate some common logs without a calculator. Okay, so if we look at this, the log of 100,000, well, that's the log of 10 to the 5th power. That 10 to the 5th power is 100,000. And we just learned that the log and the 10 cancel, so that is 5. The log of 1 is 0, because 10 to the 0 power is 1. And the logarithm is an exponent, so the log of 1 is 0, because it takes an exponent of 0 to get an answer of 1. Log of 0.0001 is, it is -4. It's -4.